Let's try that today. Always practicing, always working. Okay, and that's rolling. So we said that the height here, it's buried. We won't be able to see because it's in the dirt. So what are we gonna have to do? Who remembers, we talked about definitions last week. Does anybody remember what a TP? TP was something we had up on temporary point or turning point, temporary point. Yep, either of those two would work. We need to set a point. We're going to set a new benchmark, a turning point. We want to find a point that we can use to move the level that we can call this a benchmark, so that we can make a jump. So what did we do in this case? We pounded a hub in the ground. We've got a mark. We put a keel mark, a PK nail, any of the marking things that we kind of looked at in week 1. We're going to set something here. Do you think that I could make the turning point on the grass? Could I use the dirt? What do you think? Just thinking about something where I need to set a temporary benchmark that I can put the rod on, that I can use to move down the road. What do you think we would have to do with that point? Can it be
down?
Pound it down. Can it move?
It can.
Do we want it to move? No. Does everyone understand? If we set a temporary point somewhere, we want it to be hard, because what's going to end up happening? We're going to take our survey rod to that. Let's just use this plus right here. Let's just say I'm using this. This cross right here is my temporary benchmark that we're setting. I don't want it to move, right? Because if Logan's running the instrument and we're going to set this point, and I can set this in a hard place, I get a good elevation on this. I know what it is. Now, we're going to go that way. Derek's got his instrument down there, and he wants the backsight. We want to use something that's still solid, right? If this is on grass or mud or dirt, this can move, right? And if this can move, if I could shove this in the ground, it's going to be, the reading that Derek gets on it isn't going to be the same as the one that Logan had, right? Does that make sense? Mm-hmm. So also think too, if we set something in the ground that's solid, if we set something in the ground that's solid, so let's say, just for instance, we're in the pavement and we put a PK nail in the asphalt. We're going to set this in the ground to be this temporary point. Could I use this again for a shot later on? Mm-hmm. Right? This is now going to be a mark that's in the asphalt that's going to be there after we leave. 2 weeks from now, if we have an elevation on this temporary point, we can use it again, right? So building in that to just say, I'm going to put something temporary here, but it's temporary, but we still get to use it. If I pounded a hub, you guys will do some, we're going to throw hubs in the ground later on once it warms up. You know, a lot of times you'll see these, you'll see these on the ground or accompanied with a lap. If you pound this in the dirt and get it nice and deep, this is solid. We can use this later on. So that's what we're talking about, a turning point. You guys will set some turning points for yourself today while you're doing your shot. So just think about that. We're going to have to kind of move the level and move the instrument. So in this case here, what did we do? We said we got our shot, 0.982, and we want to find the elevation of the TP. What are we going to do with this number to get to that? Subtract. Does everybody see that? The HI minus this point, we're subtracting, gets us that turning point. And we're not really cranking out numbers, we're not formatting anything, we're just kind of thinking with how we were going to do this operation. So once we have this elevation, now what happens? Can we take what we did here and just move it over here? Mm-hmm. And in theory, we're going to do what we did here over here. So we're just basically setting the instrument up in a new place, and we're starting over. So we're going to say our instrument is here. I have an elevation here. What do I do to start?
Plus.
I take a reading, I add the backsight, right? And I get a new HI. So now I have the second HI. I'm in a new place. I'm now higher than the benchmark, so what can I do? I can put the rod on here, I can take this reading, and now I can do the math. This minus that, right, gives you that elevation.
But looking at, I mean, I know, looking at the elevations, which are only a couple feet difference, if you started at location 2, you technically could shoot everything. right? If your rod's tall enough, you know what I mean? Like,
Yeah.
okay.
Does Derek raises a great point. Let me find a straight edge here. Derek is saying, what if I went over to position 2 and I took that reading, right? That's what Derek's saying. If I set over to position 2 and I took that reading, I could do this in one step. You guys see how that could play out? So let's think about what we've been doing so far. How far away, how much further away am I going to be from this point to that point? It's a lot farther, right? It's a lot farther to take this reading than it is to take this reading, right? So the instruments that we have, let's just say 150 feet, maybe 200 feet, would be about as far as you would want your partner away from the level to be able to get what would be a pretty good reading, a pretty accurate reading. If we thought that this was 150 feet, and this was 150 feet, and this was 150 feet, we are now 450 feet from this rod. How do you think you'd be able to get an accurate shot being that far away? Right, it's tough. It's going to be tough. Let's factor in some of the things that we talked about early in the class. What factors come into us taking a good reading? What are some of the things that if you're sitting behind the instrument and you're taking a shot over here, what do we have to think about to minimize our errors? What are some of the things?
Clear sight.
Clear sight, right. What else? Keep rolling. Just holding the rod straight. Sam, excellent.
Wind.
Wind. Yep. Keep going. You guys are on a roll. There's lots more. How about the weather?
Yeah.
Heat. 450 feet on a 90-degree day on pavement. The heat waves are going to play. All those things can factor into why we can't go. How about this? How about our eyes? I mean, our eyes are going to look through that scope a little different. Some of you with really good vision are going to be able to see better. You got good eyes, right? Gabe was telling me, like, what is it, 20/10 or something like that?
No, I was joking. I was like 40/20.
40, whatever. I got to squint at anything now. But just our eyes and our focus. The instrument itself, too. There are, they call it powers of magnification of these instruments. You know, these are basic instruments. These are good for construction purposes, but they're not good for really long shots. They make instruments that obviously cost a lot more money, that are more accurate and allow you to see further. But does the instrument we have allow us to go 450 feet? So it's all those things play in. So for the purposes of what we're doing, my plug number has always been 150 feet is about as far as you'd want to stretch. So, but no, that's good. Derek, I'm glad you brought that up. It's good.
So if you're using an instrument that has that span where it can be bigger than 150 and you still use that temporary point,
Mm-hmm.
can you use the first dimension or where you started at for the benchmark for, was that 460,
Uh-huh.
to do like your check to go across? I mean, could that be like where Derek was saying, can you just go back and measure, you know, go from that benchmark and go over?
Okay.
Can that ever be like your double check, or because of the?
Oh, I see what you're
slope?
saying, Maria.
Yeah.
Maria, you're saying that if I'm at point 2 and I finish this all up,
Yeah.
and I need to, what's the term we use when we have to go back to the original spot? Closure? Closure, we
Yeah.
close. So if we needed to come back and close on this, could I just simply sit here and take that 450-foot reading and see it? That would then say, is the shot that I'm taking to close going to be accurate? How about this? That's a great question. If I was sitting here and I said, hey, let's just eliminate this step and we're going to close from here, and you got a number that was 7/100ths difference, was different than what you started, would you feel comfortable that all your data worked? Maybe not. I might be concerned if we just turned back here, took a reading, and it gave us a different number by a bit. Then I'd be nervous. Then I'd be scared and think, we just did all of this work, but I didn't close. Does that make sense, Mary? Am I answering the
It does,
question? Yeah.
I just wanted to, that span, and with his question,
Yeah.
how that temporary mark.
Yeah.
Can that be here?
You could, okay, and Maria, maybe you're asking, can I just turn back here and close on this? I don't know if that.
I was looking at like starting at the benchmark 460.
Okay.
He says he's going up.
Uh-huh.
Using that point to go all the way across. kind of
Okay.
eliminating the temporary point.
Oh, I see. Could you set the instrument here? Or is that
No,
back here?
at the beginning, yeah.
Okay.
Yeah.
Yeah, I think the issue is line of sight and being able to see what you need to see versus the whole distance that you have to shoot to get
I
something
guess I
done.
thought it that way because if you're saying other higher powered
Yes.
instruments that gives you, go from A all the way to B.
You might
If
be
you
able
can
to
get that
see.
clear line of sight,
Sure.
and that be your closure or your check.
You could, yeah.
I guess that's what I.
Yeah, okay, so if you could sit somewhere in here and maybe shorten that shot with a higher power instrument and extend the distance so you could see more, yeah. The power of the instrument will tell you basically how far you could go. Yeah. Crystal, yes. This one's actually in metric. Yeah, it's in metric, but the numbers will still always work it just has an extra decimal point to it. We could say, Crystal, I could say, well, this is really a tight bench loop in tenths, hundredths, it's in thousandths of a foot, But I know with 3 decimals, these are usually set in metric. But. Oh, like this? I think for the purposes, Crystal, was 165, 136. How about this? If we just did, I'm going to do this. Let's just say these are feet. What it would say is that we are really good at taking our shots, like really good, to the point where we could look at this 2, and what do we know this point is right here? Yeah, good pointer. So this is 2. What is that third game? 2. What is this point here? 2 point what?
01.
201, right? 201. I'm going to draw on this right quick. What if we could say that is 2.007 that we can split, okay? That you're basically taking this white space, which is 100th of a foot, and you're trying to split it down into what you think it is. So that's really high accuracy stuff. How about this, Crystal? Since it's a great question because I want to show you this. It's out of my field book. Real world. When we ran some level loops for some benchmarks, which is kind of what you'll be doing today.
Wow.
So we do them in feet. But you'll notice that when I took the shots, I went 10th, 100th, 1000th, which is, Crystal, just what you asked about. I think for my eye at 150 feet, I feel pretty good that if I was in the middle of those two, that white hash, I'm just gonna call it a half, just a half. So when you guys are out doing your shots, you don't have to do it for this class, but you could think about it. Sometimes you're gonna be in the middle of something. For the purposes of this class, just pick one, higher or lower, that's okay. But when we're out doing a level loop where we wanna try to check the closure on something, I just said I'm gonna go to the thousandths, I'll split it. That way I don't have to guess. I'm just gonna say what I think the reading is, so. Crystal, that's a great question. So in the cases of this, 3,000ths and 8,000ths, this person that was reading this instrument was really good. I can't, my eyes aren't that good to get to thousandths like that, but. So, let's do 940. Tell you what, that's a good smattering. What we're gonna do is we're gonna come back, we'll take a little break here, grab a water or something. We're gonna set the field book up for how to go through this process. So we'll find how to get this on paper so we can run the numbers. Okay? So let's come back at 10 till. We'll come back 10 till.
So you just want us to have a clean sheet, just
Yeah, you can use it. Yeah,
set up another one.
Just go for it. Yeah, you got so many pages in these books, Gabe. You can set that up right there.
Appreciate it.
Yeah.
And all of his old leads that
Yes.
came in the tubes and everything. Yeah, all the different types of leads.
And it was craftsman. That was craftsmanship for people that made drawings.
And
Those
that's-
tools
yeah,
were
and
just
he could
it.
have
Yeah.
been like over 100
Yeah.
now, I think.
Do you know
Yeah.
the location? I think it's on Cash Street. There's like a drafting equipment.
Is there? Yeah.
Yeah, but I don't know if it's still open or not. I think it's just
Do they still have it? There and those.
I've seen the drafting boards, and that's what caught my attention when I used to go on runs.
Yeah.
Through downtown.
Drop in there and see, because I'm sure they have lots of the old pen sets and
Yeah,
tools
they
and
have a
things
bunch
like
of
that.
them.
I'll
Yeah.
bring it in, you can take a look at what I've
Yeah.
got. 'Cause I looked at it, thought it was super cool that they gave it to me, and I put it up in the closet, and it's been there for the
Yeah.
next couple of years.
But that's something you couldn't get rid of. That you know, that's what I mean. It's just
I don't know
gonna.
what to do with
What do
it.
I do with it? But
I'm
it's
never gonna use it. But it's kind of cool.
that is
What
awesome.
they thought of me when they were going through all this stuff, because they, like, he was a drafter, and talked about Maria's gonna love this stuff.
That's right. Yeah. Just because you're in construction, she's gonna love it. Right?
Yeah.
All right. Well, let's jump. We'll jump in. So, let's go through and figure out how to put a field book entry together for this. So let's go ahead and you guys can do. Gabe was asking, and there are so many pages in your field book. You guys don't need to use loose leaf sheets. You can just take a blank sheet in your book. You're not going to run out of pages in 16 weeks here. So you can put this stuff in your field book. Your field book you can use it on your midterm and your final. So if there's stuff in your field book that you like to use, examples or whatever, that is fair game. So let's take a look at this. So we're going to learn today how do we get 2 level setups in one book entry. So let's go ahead. I'm just going to write here up on the top, job info. What type of job information are we always putting in the top? I'm keeping this generic. What goes up here? Lots of different stuff. What? Crews and what they're using. What else?
Location.
Location. What else? Date. Yep. Day and date. What else? Cold, windy, cloudy, sunny,
Weather.
temperature. We'll throw that up in the top. The crew, the equipment, job name, what the task was. So I'm keeping this generic just for sake of brevity, but keep being diligent when you guys are putting your stuff together for your classwork. Okay, so what are our column headers? We said it's our station, backsight, HI, foresight, elevation, and notes. And above backsight, and I'm going to do this here today. So backsight plus and foresight minus. And this, you guys are going to, you'll tire of having to write these column headers, but that's what we use every time. All right, so what are we going to, let's put the first point in. So let's say that the first point is benchmark 460. Sure, you know. And its elevation is 161, 273. And out here in notes, let's just say it's a hub. All right, so we've got our backsight. What are we going to do with that? We're going to add it, right? So our backsight is 2.868. Grab your calculators. Well, actually, you don't have to because the numbers are already written there. But so our elevation plus our backsight gives us 164, 141. Right? So the next thing we're going to do is we're taking the shot at TP1. So let's go ahead and drop. We can drop a couple lines. Say TP1. And what do we do? When we turn the instrument and we shot TP1, we got 0.982. And what are we going to do to get the elevation? Subtract it. Agreed. So let's do a minus here. And we got the number. We're just kind of filling in the box so the field book matches with the sketch. 159. And let's just say this was a PK nail. Okay. Sorry, I'm running out of room here. Everybody see how we got there? This was like last week, just doing a little loop. All right, now here comes the unique part. So we're going to be backsighting TP1. We know it's a PK nail, and we know what its elevation is. So let's just take these 3 pieces of information. This, and this, and this. It's the same as this, and this, and this, and this. I shouldn't say that. Same as the benchmark and the elevation. So we're going to use the same information. We got the turning point. We know its elevation. we got to get a new HI, right? So what's the backsight? What is our new backsight? So we picked the instrument up. We went over here to number 2. We've got to get what? We need a new height of instrument. We got to get a new HI, right? So we set up over here. We now shot the turning point. What are we going to do with it?
Add.
We want to add it. So where do we put it? So we're going to come over here in the table and we're going to say the new backsight now is 1.977. So just like we did in the first setup, we're going to take the elevation plus the backsight and we're going to get this new HI. Does everybody see how I got it? So same thing. So our turning point is now our benchmark. So we're starting with. We got a new backsight, so we get a new HI. So then the last thing we're going to shoot is what? Benchmark 461. Benchmark 461. What was our shot? 0.540. What do we do? Subtract it, right? So we get 0.540. 164. 596. And let's just say that's another help. So everybody see it. So one of the things that we can do here is just a little graphical help. And you don't have to do this, but just a little. That HI the HI minus this gives you the elevation. The new HI minus that gives you that elevation. So I don't know if that helps, but just in terms of thinking how the order is set of how you do the math. Do you guys see it?
Mm-hmm.
See the pattern? So so how about this? You guys see it? This should be a good example for how to have 2 setups and find the new elevation of something. So here's what I thought we'll do. Let's do this. You can open your books if you got your books. If you don't, I'm going to throw it up on the board here. How about you take some time and let's do, I ran copies, so excuse the, so 4.2 in the book. And this is actually one of your homework problems for this week, so. How about we go through, I'm going to let you work on your own on 4.2 using the same method that we just did in our example. Run the level loop. Run the level loop for this. Let's go ahead and run the numbers. Let's see what you get for TP1 and TP2. So you blank field book page. I think maybe Gabby asked too. You know, in the case of something like we're doing here, where we've got half of a page and we've got a couple of shots, you can always just in your book, if you want, just draw a line and you can start a new, you know, a new entry here if you want. But like I said, you have enough pages in your book where you can take a blank field book page. And I always have too, in case you ever want them. I always keep blank loose leaves of field book pages, so you can always grab one of those. So let's take. How about shouldn't take more than 5-10 minutes. Just work through 4.2.
Go a couple more. How's everybody coming? Okay. Sam, got it? Anybody got all the way through? Sam's in. Logan? Get it? Got it? Okay, Logan's ready. Yeah, we'll go a couple more minutes and then we'll go through it together. All right. Let's go through it together, see how everybody did or is doing. Yeah, we'll make that. All right, I'm going to save a little time because I already worked these, so we'll just kind of go line by line. So I'll start with our column headers. I know everybody got that. Let's go ahead and take a look at the first. What's the first thing we got? So the setup is 313.77 is our elevation. Our reading was 1.27, so we're gonna add it, right? So I got an HI of 315.04. How'd everybody do there? HI good? Mm-hmm. Thumbs up? Okay. So we're gonna take that next foresight shot, so we're coming to 491. Let's forget about this for the time being. 491 is our reading. Mm-hmm. So how did everybody get 310.13? Mm-hmm. Good there. Okay. So we pick the instrument up, we move it to a new spot, so we've got to start over. So all we know is an elevation. We got to get a new HI, right? So we shot 2.33, HI of 312.46. We like it? Gabe says yes. Anybody else like it?
So we take the 2.33 plus the 310.13.
Yeah.
Okay.
So and maybe we'll walk through this line because there's a lot of information on the line here. So if we kind of keep mark up my nice homework here. I'm gonna mark it up, but that's all right. So that we're taking that HI because there's a lot on this line. We're subtracting that. We've got the elevation of TP1. We're going to use TP1 as our backsight, as our benchmark, and we're going to take that other reading that's going to give us this HI. Does everybody see that? There is a lot on this line, but there's also a method to the madness because everything that happened on this line right here is what we know about TP1. And that's the reason we set up our field books the way that we do. Everything that happened with TP1 is all in this one line. Because what happened? We determined what its elevation was here, but we also used it to get an HI to set that up. So anything that we did on TP1's in one place. So, and then what's the last thing we do? Take that last shot at 617, subtract it, and we got 306.29. Everybody get 306.29? Yeah? Shakes of heads? Yeah, Bri? Yeah. Yep. Okay, so one thing we haven't, let's look at the problem, and the problem also asks, show the arithmetic check. So what is that? We haven't talked about checking yet. When we closed our loop, remember when we said the last shot we want to take, we want to close it? We want to see that it's the same reading, right? It basically says the level loop that we did. Let's take a look at this problem, and let's go back to what Derek asked earlier. straight edge here. About if I could just take one shot. If I could set in one place and instead of having two setups, if I could just take one shot. So if we could just do this. And take one shot. If we could do that, let's just kind of look at the picture and let's just think about what that would be. Our original backsight would be this over here, right? We'd be plus in that. But when we came over here, we would just be taking whatever this is here, we'd just be taking one shot. You guys kind of see how that goes? We're forgetting this. There's a really interesting thing that you can do when you have a level loop. If you have the ability, and I'm just going to roll this out here, and the arithmetic check is basically saying, if I add up my total backsights, in other words, how far did I go up every time I took a backsight? And if I added up the foresights, how many times did I go down? We went up twice when we took two readings, and we went down twice. If I add these two up, I'm going to get, what was my total up? How far up did I go? This plus this is how far up my instruments went. And if I added these two guys up, this is how low I went. You'll notice something here. If I take the difference between what I went up and what I went down, so we sum these two columns up, and we get this difference. This 748 is the difference. That 748 is how much I went up total by how much I went down total. Well, what should that be? It should be the elevation that I started, difference with the elevation that I ended up at. So the check is, if you guys look at these two columns, I take this minus this and I get 748. Look what happens here. If I take the starting elevation and the finish elevation, I add those up, it's also 748. So when you have a level problem like this, you have the ability to check your work. You can sum the column here, sum the column here, take the difference. That difference should be the same as where you started and where you finished. So the long and short of this is, anytime you're doing any of these level loop problems, when you have them on a quiz or on a midterm or you're working in the field, you can always check to see that you got the right answer. You'll never be in a position to say you should have a wrong elevation somewhere in there. It's cool. It's just kind of cool. So when we talk about an arithmetic check, that's adding this column, and checking the difference between the two. You guys kind of see it? It's basically how far did I go up in total and how far did I go down. You're just checking it. Think we get it? It's a good example. How about this? And if you guys have this in your book or your notes, just working this problem and the one that we did before, you'll be using that. You're gonna use that for your homework and some different stuff. Okay? Questions, comments? Did that go okay for everybody to kind of work through the system? It's really what it is. It's just following a system, just being deliberate and putting numbers in boxes and just adding and subtracting. So let's do this. The second problem, which is 4.3. So your homework this week is 4.2 and 4.3. Let's take a look at 4.3.
Oh, there's a lot of lines.
We got a lot of stuff going on in 4.3. What I want to do with you guys is 4.3 is let's get the book set up, and then for your homework, then you can work through the numbers and calculate it. So what we're doing on this problem, let's kind of take a look at what kind of shots we're taking, because there's some extra information in here that might look a little different. So we're setting up the instrument, and we've got our benchmark, right? So we know we're going to get our benchmark 472 is the reading that's going to give us our HI, just like we've been doing, right? But what they've asked for is they want some extra shots. They want us to take a shot at station, right? This is a station. You guys remember the little plus? They want us to take a shot at station 0 plus 0, 0. So something's going on. We're on a road. We're on the center of a road of whatever we're shooting right now. So they want to know what is the ground elevation at station 0. They also want to know what the ground elevation is at station 0 plus 50. So they've taken this extra shot here at 442, and they've taken a shot at 430. So you can calculate. So let's think about this. What is my 472? I'm going to do what? Add or subtract 472?
Add.
We're going to add 472, right? So we'll be able to get our HI. That's going to equal something. Now they said take a shot at station 0, and we got a reading. What would you consider this 442? Is this a backsight or a foresight?
Foresight.
Who says foresight, right? Foresight. Even though we think that the instrument is pointing in that direction, we think we're going back, but really we're going to be taking a foresight. This is a shot. And what are we going to do with that 442?
Subtract.
We're going to subtract it, right? We're going to subtract the 442.
How did you identify that was the foresight? The 442?
The 442,
The location of it?
if we think about, how about, Marie's got a good question. So think about our process. Our process is we go out, we set up our level, we have an elevation, we need to know the HI, so we take a backsight, right? The 472. So that sets our height of instrument. And what did we say? Once the instrument is on the tripod, once I get my backsight and I establish my height of instrument, how many shots can I take to determine elevations of things around me?
Infinite.
1, 2, infinite, whatever we do, so long as the instrument stays where it's at. So this is the first shot that we're taking using the instrument where we know that it is.
After we have our backsight.
After we have our backsight, right?
Okay.
So that means this is going to be considered a foresight,
Okay.
right? And what are we going to do with the 430? We know we're going to subtract that, right? So this is actually another foresight. Does everybody see that? Because that is where it can get a little confusing. Now, I'm going to give you the cheat code for the first one. So let's take a look at 4.3. I don't know if I can get all this on one screen, but I'll try here. Let's just look at 4.3. All right, cheat code. So there's the bottom. So how would we set up a field book when we've got multiple foresights? What you're seeing on the screen is how we do that. I'll fold this up here and try this. So let's look at it. So 320 is the hub elevation. 472 is the backsight. So we got our HI. So I just jot this in. This is now 324.92. And now we have two foresights, right? Does everybody see that? We've got the station 0 plus 0, 0. We took the shot at 442. So now we know that the dirt elevation there is 320 plus 50. And if I was to do this, little arrow, minus, equals. And we took another shot. We were in the same place. We didn't move the instrument. The HI is exactly the same. We took a shot at station 0 plus 50. We read 4.30. So the same thing happens. You do that, minus, that equals. Still minusing at the arrows there. And if we had more shots, if we went at 0 plus 75, if somebody said there's a manhole, we're just going to keep racking up foresights. Because once that instrument is set, we get to shoot anything we want. Because we're always going to come back and use the same HI. Does everybody see that? Because you're going to be doing that today. When you go out and do your training today, you are going to establish an HI and take a couple shots. So that's how you do it. All right, I'll give you one more cheat code then. So let's go. So what happens then? We finished up, right? We finished up our shots over here. We picked the instrument up. We moved it. So what does that mean? We need to get a new HI, right? Every time we put the instrument somewhere, we need to get the HI. What's the last shot that we took? 2.01?
2.01.
2.01. So before we broke the instrument down, we needed to get that last foresight, right? Because what does that last foresight give us?
An elevation.
Gives us an elevation. I'll keep these covered here so not to confuse. So we actually took 3 shots, right? We took 3 shots from that one spot. Station 0, station plus 50, and then the turning point, 2.01. And just like we did in the first example, so we calculated what the TP1 elevation is, 322.91. All right, and I'll move my fingers. We picked the instrument up, we moved it over here, so now we got to start over. What was the shot 511? What do we do with that?
Add.
Add it, right? That's our backsight. We get a new HI. So how many shots are we going to take on the last setup? How many do we have? We got station 1. We got station 1 plus 50. We got 1 plus 75. And then we've got the benchmark. So we're going to have 4 backsights or foresights? Foresights, right? All these shots are going to go in the foresight column. And they're all going to use the same HI. So I won't give you any more cheat codes. I'll let you solve those. But you have the HI there. So that would be the completion of problem 4.3, which is for your homework this week. So 4.2 and 4.3 are part of the homework assignment. All right, go ahead. Come on, Bob. You have other problems to work too, so I can go ahead. I'll go ahead and do the reveal here, but let's just don't run the numbers. I'd like you to run the numbers yourself. I'm sure you're going to get them all right. So we've got 4 shots: 1, 150, 175, and the last turning point. Now, when we do our arithmetic check, let's look at what are we going to check. I'll let you guys run all these numbers up by yourself. What did we say? We've got to add up how high and how low we went, right? So we know 472 and 511. If I add these 2 guys up, this is how high I went in total. Let's think about all these shots. Am I going to add up this entire column of shots? Do you think? If this is how high I went up when I had my instrument set up, I don't want to add all of these up, right? Because I've got a dirt shot and a dirt shot. It's got nothing to do with the level loop. But what are the 2 numbers that I do care about? I care about that one.
First and the last.
And I care about that one. Those 2. The 2 with the asterisks. Because why? These are the shots that dealt with the turning point and the final benchmark. I'm going to let that sit. Just let that digest a little bit there. 2.01 was the shot on the turning point, right? 1.80 was the shot on the last benchmark. So I would just want to use this guy and this guy when I do my check. Because all these other dirt shots are just dirt shots. They don't deal with the level loop and the benchmarks and the turning point. So when we do our arithmetic check, we're just going to use those 2. So what did we do here? If you run the numbers out and I take 2.01 and the 180, 3.81, if I take the difference between this and this, I get 6.02. That's the total difference. So let's go back. Check this hub. With this crosscut, where did I start and where did I finish? It's 6.02. So it matches. We checked our work. our math works, everything that we did for this setup matches. So the bottom line is when you do your check, don't let all these extra miscellaneous shots get in the way of just checking what you did on the benchmarks and the turning points. So these are two good examples as you work